Thanks for joining us all today. So today's webinar is all about planning for a large flooring project and the design considerations around this. It's for flooring in the food and beverage manufacturing industry. So today we've got on with us Josh Gillies and Michael Arnott, and I'm Bridget Gillies. Today we'll be discussing the requirements for flooring in food and beverage manufacturing facilities, and then we'll define what a food-safe, food-grade floor is, and then we'll go over some important design factors and considerations for planning a large flooring project. So flooring is one of the most abused surfaces in the food manufacturing facility. From large machinery rolling over it to extreme temperature variances experienced within minutes, the floor must take it and not crack or damage. For a flooring project to be successful, the floor must be designed specifically with the individual room requirements in mind. Most of all, it needs to be hygienic, functional, tough, and safe to walk on. And as we all know, it's because failures, even seemingly insignificant ones, they can cause expensive downtime, production losses, product contamination, and in worst cases, accidents. So the requirements for flooring in food premises, they're quite long, as all requirements are, but we've split them up into 5 key areas, and these are all just based off the requirements in the standards 3.2.3. So the first one is that floors must be easily cleaned, and this is one that flows onto the next one, being that it needs to be smooth but still have some slip resistance. So it's important that it is able to be easily cleaned, but it also must have enough grip so that people don't slip. It must be resistant to hot water, steam, and chemicals. So this is because these 3 features, including acids, they'll break down the floor if it's not resistant to those, and cause cracks and crevices that bacteria can then grow in. And then this is an interesting point, point 4, ensure that the flooring solution is the right one for your needs. So it's fairly obvious, but it's set out clearly in the requirements, because there are so many different areas within one facility. For example, production versus a warehouse. Production, they need a lot more durable floor than a warehouse. So it's important to get that right, and we expand on that further later on. There's actually no requirements for sanitizing the floor. It's may seem obvious, but it's because no food is in direct contact with the floor. Obviously, cleaning is very important, but there's no actual requirement that the floor needs to be sanitized. If you'd like to see the complete standards, they're on our website under our resources tab. Check it out there, or they're also in the guide that we'll send around after this webinar. Handing over to you, Mike.
Thanks, Bridget. So when we talk about defining a food-safe floor, the term food-safe flooring is not really something that's defined in food safety standards. It's not exactly something you can get a certificate for your food-safe flooring. Although there are companies such as HACCP that will assess your flooring as part of an overall site audit, but there's not any specific certification you can get for your floor. But there certainly is some important factors that we need to consider. As we mentioned earlier, flooring doesn't exactly have to be sanitized. It's not like workbenches and so on, where it needs to be sanitized. But they certainly do need to be effectively cleaned. And in that, there is a factor that needs to be considered. That is one of the most common ways of cleaning is high pressure water blasting or pressure washing. which involves heat and steam, which will cause any bacteria on the floor to become airborne, and that in turn obviously will be a hazard if there's people or machinery around. So there's some important design factors we need to consider. First being food safety and hygiene. First point there, food manufacturing facilities offer the perfect conditions for bacteria to grow. And for that reason, food safety and hygiene is increasingly on the radar of consumers, industry regulators and so on. But on the other hand, there are plenty of innovations and technologies in the industry that are also increasing to combat that. It is extremely important for companies to do whatever they possibly can to ensure the best hygiene standards are kept. And the best practice is, as far as flooring goes, is to have a floor that is not only easy to clean, but also actively fights bacteria growth throughout the lifespan of the floor. And just on personal safety, as you can see there, 86% of total workplace injuries occur due to slips and falls, with 90% of these happening when the floor is wet. And just on that second point there, where fruit and vegetable fat and other residue end up being on the floor, there is plenty of practices a company can implement to prevent that kind of material from falling on the floor. But what they can also do is choose flooring systems that have the best level of grip without compromising cleanability. That's a balance that's quite hard to achieve, the balance between grip and cleanability. We do offer various levels of non-slip to help find this balance. Another factor is resistance applicable for intended use. It's important to realise that there's no one flooring system that will work anywhere in your facility. It's not really a do-it-all flooring system. So it's important to find the right tool for the job, so to speak. For example, if you're looking at a slaughter floor where there's a lot of heavy machinery, heavy foot traffic, steel trolleys and so on, and also there's damages from impacts from hard objects such as hooks that occasionally might fall on the floor. We do have a white paper called A Solution for Every Room. That's definitely interesting and good to read. And then on to maintenance. Cleaning and sanitation is one of the most important tasks in the maintenance schedule. And this is what it says there, challenges with a heavy non-slip floor. We touched on it earlier, but slip resistance, the heavier the non-slip component on the floor tends to make it harder to clean and needs to be cleaned more often. And just on that point there about oily floors, places like bakeries tend to have a lot of oil build up on the floors, and in that case various detergents and solvents are needed, and they'll actually need to sit on the floor for a certain amount of time before washing it down, in which case you need to consider the amount of downtime involved. And over to you, Josh.
That's excellent. Thanks, Mike. Antimicrobial floorings we feel is very important in the food and beverage industry. You know, the the typical flooring, typical current flooring solutions, you know, whatever the product used is, epoxy or polyurethane or cementitious products of either of those. They're all very adequate flooring systems, and by their very nature, they stop bacteria rising up through the floor. They're passively antimicrobial in that they don't you know, they don't set out to harbour bacteria, obviously, and they seal the floor off. But really, one of the dangers is bacteria growing on the floor, and then that bacteria becoming airborne. You know, and that's airborne by cleaning, by the hoses, or in a dry room, it's often cleaned with air or with brooms. And the bacteria, the risk is bacteria becoming airborne, not tackled on the floor, then becoming airborne and coming into contact with food, or potentially coming into contact with food. And so that sort of caused this need to have a floor that's, you know, that's actively antimicrobial, that's trying to break the bacteria down when it hits the floor. So that's sort of shaped what we tried to offer with what we're trying to offer with the SteriFloor range. We've got a family history of you know, more than 50 years of paint chemistry, and so we felt it was time to explore this, you know, this potential more. You know, there's plenty of things that attack bacteria. Use hand sanitizer a lot more often the past 2 years, and plenty of antimicrobial cleaning products, but there's nothing. So we felt there was potential there to have a floor that could attack bacteria in a in a similar sort of way. So that's really been incorporated into every system in the SteriFloor range. You know, it's a suite of 8 or more systems, along with, you know, customizable systems depending on the application. And it's important to note that the antibacterial or the antimicrobial technology is incorporated into every layer of those systems. So, you know, often with the SteriFloor Stark system, you've got 2 top coats or wear layers, and you know, once they're worn through, it might be 3, 4, 5, maybe 10 years, depending on the use of the area and the and the environment it's used in. They can be, you know, once it gets through to that sort of base, that build layer, it's still the same. You've still got the same antibacterial properties, and that we feel is really important. You know, it's a floor is designed to a flooring system and its properties. They're meant to be designed to last. So we feel that's a key aspect of it. And and moving on to the key design considerations now. The first one is joints there. And there's really 2 things. Joints are required, obviously, for movement, for, you know, allowing for movement. If you don't have good joints, then you have cracks, and treated joints are much better than untreated cracks, where there's sort of all sorts of places for bacteria and other nasty things to hide. There's really 2 things with joints. There's a few sort of universally accepted standards with joints. The first one is to keep joints away from, or to minimize joints in high traffic or high intensity areas. This isn't always possible. Obviously, you know, one of the standards is to have joints at a maximum of 6 meters apart. So it's not always going to be possible to have, you know, no joints in high intensity, high traffic areas. But the idea is to maximize the slab the structure and strength of a slab, especially the center of a slab. So so for instance, where there might be a lot of a particular intersection of foot traffic, or a particular area where forklifts are likely to screw their wheels, for instance, coming out of one room and into another room, or into a hallway, for instance. And the idea of that suggestion is just to minimize that weakness, because joints are weak. They're a weaker part of the floor, obviously, but they're very necessary. And there's really two categories there, as you can see: designing for a new facility and an area being repurposed, and that sort of, and I suppose the same rules apply to both areas. However, one of them, the second one there, you're using an old slab, or you're using, more often not using, an existing slab. So, and a classic example here is a part of a warehouse being taken up for production, or for processing, and meaning that, so where there was once a warehouse with heavy storage and heavy machinery running over it, it's being converted into something that's not quite so intense, and so there tends to be remnants of, or tends to be indications of concrete movement, which have to be. It's really important that they're treated carefully. Another thing that we often see is thresholds or freezer entries, and this is both new facilities and repurposing or refurbished areas. Freezers, the junctions between freezer and warehouse areas, or areas that have that big drop in temperature. A freezer will be negative 15, 18, 20 degrees, and then you've got the outside area at room temperature, or 10 degrees. So it's really important that there's a lot of stress on that area. It's really important that that's thought through very carefully and planned around. One thing I was reading is an engineer saying that in an ideal world, you'd have a joint across the door, across the threshold, and then you'd have a joint. He actually suggested having 2 joints either side. So you've got sort of 5 joints in the area. Ideally, I think you'd probably have at least 1 either side, so a metre or 2 either side. And that's just to stress that's just to sort of even out that high stress environment across that area. There's a number of different scenarios like that. That's just one of them. And then moving on to drainage and falls. There's a couple of things here that they're going to change and need to be adapted to a specific scenario. But in an ideal world, drains should really be placed close to, but not under, processing equipment. That just makes maintenance of the drain and cleaning of the drain a lot easier. So one client of ours, they're a global company, and one of their standards is that all drains should be placed at least 300 mil outside the footprint of any processing equipment. And it's actually came up recently because we had to service a drain that was very close to a very heavy dryer line, and it meant we didn't have to remove a number of different pieces of of machinery or processing equipment to access it and service that drain. So I think that's a really important consideration. Obviously, drains are going to require falls to them, and there's a standard here is 1 in 100. That's what we often see, and that tends to be a universally sort of accepted standard. Some extreme processing environments where you've got a number of products on the floor other than just water might require a steep fall, up to sort of 1 in 50. other environments, dry environments, for instance, you're probably fine with 1 in 250. Again, there's no real standard on this, but the universally sort of accepted normal, if you like, is 1 in 100, 1 in 80 to 1 in 100. And drains obviously affect joints. They affect the thinking on joints. It's really critical to have especially around any strip or channel drains. It's really important to have a joint around the perimeter. It obviously, stainless steel and concrete, they're different. They're two very different materials, so they expand and contract at different rates. So it is important to allow for that. Often we see this not done, and one of the first things to form is cracks, and they form perfectly around the perimeter, and just provide another one of those harbour areas for bacteria. I'll hand over to Bridget.
Thanks, Josh. So our last point is about sustainability. So it's critical that we do what we can to use our plants' resources responsibly and preserve what we can to offset our carbon footprint for the oncoming generations. This means a lot to our company, and so in developing our StereoFloor suite, it allowed us to not only provide a sterile, food-safe floor, but also one that protects other surfaces for many years, reducing unnecessary waste of things like concrete. On top of this, our solutions have been designed to lower carbon emissions, remove VOC emissions, and other discharges typically found in flooring and throughout the installation. So this is critical to us, and we believe that we must constantly develop our solutions so that they are sustainable, and that they protect our Earth's resources for the oncoming generations. We've got an excellent article about this on our website. It's called Sustainability in Flooring, so check out that when you get the chance. So that wraps up our time. I guess one of the most important takeaways from this session is that you really plan your project around the requirements of the various areas you're designing. So even in one facility, there may be 3 areas that the project involves. Each area may require a different flooring solution, and the drainage in each may have to be different. So it's really important to do research and make the most of any available resources. We'll be emailing 2 of our top white papers, and they're both packed with advice about planning flooring projects. So take a look at them, and let us know if you have any questions.